Now I present to you Damiano, who has the challenge of standing between you and lunch. Let's make sure we welcome him warm-heartedly, because his company Artificially is the first time presenting at SDS. So yeah, really excited to also learn more about what you do, based in Ticino, targeting data science, and in particular now the talk is about EdgeAI, embedded devices. Connectivity might be bad. You need to do AI on the device. Let's hear how you do it. Thank you, Damiano.
Thank you. Thank you very much. Also to you to stay in this talk. So, EdgeAI. EdgeAI is basically the solution, neural networks or other ML solutions based on devices, small devices, like our phones, for example, or devices that are made for a particular task. But first, let me introduce Artificially, since it is the first time that we come here in SDS. And basically, Artificially is a Swiss company based in Lugano. And our task is to create and deliver production-ready AI solutions, starting from POC to industrialization. And basically, we cover a lot of branches in AI. For example, the first two, computer vision and EdgeAI, that are the topics of today, but also other branches, for example, the natural language processing, where we have our LLM solutions, completely private, that works with enterprises' data without having to share with OpenAI or other companies, but also, for example, time series and other branches. With some of our clients, for example, I think that you know Sony, but also, for example, GVB, Abacus, and other companies based in Switzerland and in Europe. Okay, we worked a lot with EdgeAI. I present 3 success stories. The first one is a solution that we provide to tech. That is a driver monitoring system. So a system that can monitor the attention and drawiness of the drivers. For example, here we are looking at the gate's direction, but also we can detect, of course, if the driver is using the phone or cigarette. And this solution was basically created on this very small device that is based on NXP IMX8+. And we obtained the certification to IDIADA, that is one of the most famous certificators for automotive in Europe. Another success story is Sony. Sony produces most of the camera sensor, also in our phones, and they are pushing to deliver neural process, so neural network inside the camera sensors, in particular with this device, IMX500. And they asked us to create a smart city solution completely based on this teeny device. And we passed the benchmark. So actually, our solution is used for smart city solution in Rome, in Italy. And they want to extend also in other cities. And we obtained better results compared to the benchmark that they reported. Last is Galvolux, but we have many industrial projects where we monitor anomalies. Also in this case, in very thin and fast devices. For example, here we monitor the glue position and weights, and we report the anomalies. Okay, so, but why many companies like Apple, Microsoft, Qualcomm are pushing to deliver solutions in EdgeAI, and also we deliver solutions? For many reasons. The first is easy, the cost. Because if you take, for example, a certain amount of computation that you want to obtain, and you buy one server that satisfies that amount of computational, and you buy many devices, small devices that has the same power, computational power of a server, you save money. Absolute privacy, okay? Last year there was this news of these private images, like the girl in the bedroom, that reported that these images was published on social media. And the news reported that these images was taken by a famous brand of vacuum robots. And for some reasons, we don't know why, but okay, for testing purposes, they shared the images to the server of the company, and some employer took it and shared with friends, and they ended up on social media. So this is a demonstration of how it is important to maintain your data, your faces data, for example, or for example, the people detection in the area, and elaborate it and discard as soon as possible, okay, without sharing this data with internet. Okay, no infrastructure is needed. If you think solutions that share your data across the internet and send your images to a central server, you need to be sure that the connection is stable across all the environment. For example, let's think our driver monitoring system or an autonomous driving system. You have to be sure that your connection is stable across all the public roads in your country. And this is not guaranteed nowadays. Okay, there are now, for example, with the language models, a lot of power is consumed for processing these giant neural networks. So here, for green economy, it's better to reduce and try reducing as much as possible with computational power for the future. And if you need to elaborate a lot of information per second, for example, autonomous driving car here, the time required for getting the images, sending to a central server, and processing it, and get back the result is much higher than the time that you need for elaborating this information. So there are many applications, real-time applications, that the unique solution is to use embedded devices. If you have only one server, of course, you have also a single point of failure. Okay, you can solve it, yes, with using cloud infrastructures, but of course the cost and the maintenance effort increase. Okay, now it's an interesting plot. Okay, here we can see the number of operations that some devices can perform in a second. In particular, the tera, so trillion of operations that the devices can perform in a single second. You see here a bunch of embedded devices, and the last row are GPU solutions. So let's take it as a server reference. It's not the best GPU, of course, possible, but yeah, we can took it as a benchmark, and we can see that it can perform 75 tera operation per second. But there are embedded devices like NVIDIA Jetson Orin that can perform also more operation per second than the RTX GPU. There are also cheaper solutions like Halo or NXP that, okay, they are not so powerful, but they are enough for many cases. Of course, it's not free, so you cannot take your giant neural network and put on embedded devices. For example, let's take GPT-4. Okay, we know that GPT-4 works well, and if we represent GPT-4, the weight and the size and the number of parameters of GPT-4 as the area of this yellow circle. Now let's take YOLO, that is a neural network that can perform on embedded devices. You see that is much smaller, okay? And you hope that YOLO works well in the domain, like GPT-4 works for text processing. So you have problems in terms of memory, but of course also in terms of performance, because you have limited computational capabilities. And if you take your network that runs on server and you run it on your embedded device, you can see that here, for example, a processing made on the server, but the predictions are very stable. Here you can see that the predictions are very noisy and the accuracy is very low. So you need to process and elaborate and make a process that is consistent, that can improve your performance on embedded devices. Yeah, embedded devices are many, and you have to adapt. When you choose a particular device, you have to adapt and follow that particular requirements of that specific devices. Okay, of course, there exist many optimization techniques that are used nowadays for solving this optimization problem. First of all, pruning. Okay, typically nowadays neural networks are giant. That they contains many neurons, many operations, but literature demonstrate that a lot of these operations are useless. Okay, so you can prune, remove up to 90%, like this paper, 90% of your operation with a minimal loss in terms of accuracy. Distillation. Okay, if you take a bigger model that is suitable for server, like the teacher model, you obtain better result, of course, but because you obtain a better representation of your problem. and the model generalizes well, and it contains a very well-featured extraction procedure. So instead of training a small model suitable for embedded device, like student model, you train before a teacher model, and after you distill. So you try to train the student model to mimic the behavior and the features of the training model. In this case, you can obtain and improve a lot more accuracy compared to training directly. Machines like humans are better performing integer operation instead of decimal, okay? Because circuits are faster and cheaper. So usually the device comes with integer support and not with floating point support. And there are math operations that can transform your operation in floating point to integer operations. But you're losing a lot of precision. So the solutions come from this procedure, that is a widely used procedure for embedded devices, that is the training-aware quantization. So instead of training your neural network in floating point, yes, you take your neural networks and we train your neural network in the way that once they are transformed to the integer operation, the loss in terms of accuracy is very low. Okay. Okay. So thanks to this combination, for example, let's take the Sony examples. We start from the YOLO V7 that you can find in GitHub or in the literature that has 6.4 million of parameters in floating point 32. You prune it, you quantize it, it makes other optimization. And our model contains only 4.5 million of parameters in integer with only a 3% loss in accuracy in performance. And so this is the model that Sony nowadays is using for AMX500 for object detection. Okay, thank you very much.
Thank you very much for presenting artificially. It was the first time, and I hope to see you again in the next years. We now don't have questions planned, but of course I invite you to ask Adriano after the talk on a one-on-one basis. Next is lunch in the schedule, and as a reminder, there's a poster session starting at 12:30, which we invite you to visit, and there's also a job wall which you can find online, where you can see jobs from the sponsors and partners of the Alliance and the conference, and maybe you find a new job there. Well, I see you later in the afternoon. I wish you a great lunch. Thank you very much.